Hi, 7th grade. Welcome to lesson 6-2, Draw Inferences from Data. By the end of the lesson, I want you to be able to say, I can make inferences about a population from a sample data set. Let's solve and discuss it. The students in Ms. Miller's class cast their votes in a school-wide vote for which color to paint the cafeteria walls. Based on this data, what might you conclude about how the rest of the school will vote? Well, let's collect the data. Let's see how many people wanted red. I see 7. How many people want blue? I see 12. Yellow is only 3. Orange, I see 4. And green is 4. So I want to take some participation to see, based on this data, what do we think the rest of the school will vote? So based on this data, we can't say for sure, but based on the data, the school will vote blue. Focus on math practices. How can you determine whether a sample is representative of a population? Well, remember from last class we said representative is if it's a random sample, meaning everyone is represented. So we're not, just asking girls or just asking boys or just asking the teacher. Someone from every group is represented in the sample, that smaller size that you're asking. Example number 1. Sasha is trying to convince her mother to change her bedtime on school nights. She gathers data on the average number of hours of sleep that a random sample of 7th grade students in her school get each night. Will Sasha be able to convince her mother to let her go to bed earlier? So, on school days, her bedtime is 9 p.m., and she wakes up at 6:30, so she gets 9.5 hours of sleep. So the step 1, Sasha displays the data she collected in a dot plot. She describes the data. About half of the dots are clustered between 9 and 9.5 hours. 9.5 hours has the most dots. So with this most dots, that's called the mode. The range is 10.25 minus 8, which is 2.25 hours. Remember, range is the highest minus the lowest. Step 2, Sasha concludes that about half of the students in her sample get between 9 and 9.5 hours of sleep each night, the same number she gets. So you can draw a curve to see the distribution of the shape of the data. So everybody gets around the same hours she gets. So an inference is a conclusion. This is one of your vocab words. An inference is a conclusion made by interpreting data. Sasha infers that about half of the 7th graders in her school get between 9 and 9.5 hours of sleep each night. Sasha will probably not be able to convince her mother to let her go to bed later, because the same amount of people, the majority of people get the same amount of sleep she does. It'd be different if the majority of the 7th graders got less sleep than her. That might have helped her convince her mother. Let's try it. Dash collects data on hair lengths of a random sample of 7th grade boys in his school. The data are clustered between blank and blank inches, so that first cluster is between 1/2 and 2 inches. And then the next cluster is between 3.5 inches and 4.5 inches. Dash can infer from the data that 7th grade boys in his school have both short hair and long hair. How does a dot plot help you make inferences from data? It helps you easily spot the mode. So which has the most? In this case, there are the most amount of people that have 4 inches of hair length. And it's easy to spot clusters. Clusters is where there's groupings of a lot. All right, example number 2. Draw quantitative inferences from data. Quantitative means it's an actual number. So Sasha's friend Margot suggests that Sasha calculate the mean and median of the data set to determine whether they support her previous inferences of the population. The mean is about 9 hours and 16 minutes. The median is about 9 1/4 hours, or 9 hours and 15 minutes. So an inference is valid if, based on the representative sample, there are enough data to support it. A valid inference is one that is likely to be true about the population. So the mean and median support Sasha's inference that 7th graders get an average of 9 to 9 1/2 hours of sleep each night. So remember, to find the mean, that's the average, you have to add them all up. So this would be, there's 1 8 plus, there's 2 8 1/2s, 8.5 plus 8.5, plus there is 3 8 3/4, so plus 8.75, plus 8.75, plus 8.75, plus there's 4 9s, 9, 9, 9, 9, and 4 9 1/4, so plus 9.25, plus 9.25, plus 9.25, plus 9.25, plus 9 3/4, 3 of them. Oh no, only 2. I skipped 9 1/2. Boop-a-doop. Alright, but you would get the point. You would do this all in your calculator. You add them all up and then divide by the number of numbers. This is a mess. And then to find the median, you just cross one out from the lower and one out from the higher and do that until you get to the middle. This is nice because they're in order for you. So then you would see that the median is at 9 1/4 and the mean they calculated already for us. Alright, example number 3, calculate inferences based on data samples. Margot and Ravi are also trying to get their parents to let them stay up later. They collect data about the number of hours of sleep a random sample of 7th graders get each night. The 2 box plots show their data. Do Margot and Ravi's data support Sasha's inference about the number of hours of sleep each 7th grader got? So hopefully you guys know about box and whisker plots already, but this middle line is the median. The farthest whisker is the highest number. The lowest number is the side whisker here. And then this is called Q1, quartile 1. This is called Q3, because Q2 is the median. And all that means is Q1 is just the middle between the lowest and the middle, and Q3 is in the middle of the highest and the middle. The 50% of the data is within the box. It's 25% per each part. So like the first part, this is 25%, then this is 25%, which would be 50, this is 25, and this is 25. So the median time is 9 1/2 hours in each random sample. However, based on the box plots, Margot and Ravi can infer that less than half of the 7th graders get between 9 and 9 1/2 hours of sleep each night. So this data does not support Sasha's inference. They found that by, if you go to 9 1/2, 9 and 9 1/2, in both cases, between those 2 red galaxy colors, it's less than the amount that's in the blue boxes, and the blue boxes count for 50%. Try it. Alexis surveys 3 different samples of 20 students selected randomly from the population of 492 students in the 7th grade about their choice for class president. In each sample, Elijah receives the fewest vote. Alexis infers that Elijah will not win the election. Is her inference valid? Yes, because they were representative samples, because she used random. And she did it 3 different times. 3 different times, 20 random students. So she essentially surveyed 60 students out of the population of 492. And in all of those 3 samples, Elijah had the fewest votes. So Elijah will probably not win the election. Example number 4 on the next page. Make an estimate from sample data. Derek is writing a report on cell phone usage. He collects data from a random sample of 7th graders in his school, and he finds that 16 out of 20 7th graders have cell phones. If there are 290 7th graders in his school, estimate the number of 7th graders who have cell phones. So this goes back to writing our proportion. We have 16 out of 30. 16 is your part, and 30 is your whole. 16 out of 30. That's where they get this from here. Then we need to know how many out of 290. 290 is the total amount of students. If that's the total, that's also going to be the other whole. So we don't know what the part is for that one, so that's why we have C over 290. So you can do 2 things here. You can cross multiply, or you can just try and get C by itself. You can see that C is being divided by 290. That's why they multiplied by 290 on both sides, because it would cancel out on the left. But if you wanted to cross multiply, and I'd be totally fine with that, all you have to do is 16 times 290, which gives us 4,640. Set equal to C times 20, which is 20C. Then divide both sides by 20. And you get the same answer. C is equal to 232. So based on this sample, we don't know for sure, but based on this sample, about 232 7th graders in Derek's school have cell phones. Let's try it. For his report, Derek also collects data from a random sample of 8th graders in the school. He finds that 18 out of 20 8th graders have cell phones. If there are 310 8th graders in his school, estimate the number of 8th graders who have cell phones. So we have 18 out of 20 is equal to, we don't know how many 8th graders have cell phones, but we know there's 310 total. So we cross multiply. I do 18 times 310 to get 5,580. And C times 20 is 20C. Divide both sides by 20. Cancels out on the right, and C equals 279. So we would say about, because we don't know for sure, because we're just basing it off this data, about 279 8th graders have cell phones. Key concept. You can analyze numerical data from a random sample to draw inferences about a population. An inference is basically an educated guess. Measures of center like mean and median and measures of variability like range can be used to analyze the data in a sample. All right, 7th grade, let's say it. I can make inferences about a population from a data set. Have a great day.